Use a calculator or computer software to generate a normal quantile plot for the data in the accompanying table. Then determine whether the data come from a normally distributed population. Okay, so recall that if we want to create a normal quantile plot or normal probability plot is the graph of points xy, where each x value is from the original set of sample data, and each y value is the corresponding z-score that is a quantile value expected from the standard normal distribution. Now, if the points on the normal quantile plot do not lie close to a straight line, or if the points exhibit some systematic pattern that is not a straight line pattern, then the data appear to come from a population that does not have a normal distribution. If the pattern of the points is reasonably close to a straight line, then the data appear to come from a population that is a normal distribution. So let's first go ahead and take a look at the data, and then we're going to open this data up in the StatCrunch. Okay, so when we open up this data in the StatCrunch, what we're going to do is we're going to create a QQ plot. So let me go ahead, pull this up again here. Okay, so our goal is to create a QQ plot. Alright, so we're going to go to graph. Okay, well over here, why don't we just call this x value? Because what's going to be important is that in the graph you're going to see that the x value should be located on the x-axis. So, and you'll see why in a second here. When we go to graph, we're going to scroll all the way down to QQ plot. Okay, and then we're going to select the x value, and then we're going to go ahead and then select compute. Now, I'm going to come back and edit this, and I'm going to show you why. So I'm going to show you, here is the graph, and you see how this says the normal quantile plot down here, and up here says the x value. When we look at the graphs that we're given, the x value is on the x-axis, and the z-scores are on the y-axis. So we need to change this. So in order to do that, we just need to go to Options, select Edit, and down here we want to make sure the normal quantiles are on the y-axis. So we're going to select that. Now let's select Compute, and now you're going to see that the x value is located down here, and then the normal quantile plot, the z-scores, are over here. So now we need to compare this graph with the graphs that we can see here. So the first graph here, okay, doesn't look like that kind of a graph. Okay, if we take a look at B, well, you can see this graph looks pretty similar because you can, if you compare it with this graph, you can see what's happening here. So we have those right there. So you can see it looks pretty close to B. And if we look at C, it's not C. So therefore, the answer is going to be B. Okay. Now the next thing is we want to determine whether the data come from a normally distributed population. Now again, let's go back and review. The population distribution is normal if the pattern of the points on a normal quantile plot is reasonably close to a straight line and the points do not show some systematic pattern that is not a straight line pattern. Well, we can see that from that graph, it's not a normal distribution. The population distribution is not normal if the points do not lie reasonably close to a straight line, or the points show some systematic pattern that is not a straight line pattern. So we know it's going to be not normal, so it's going to be either between B and C. Distribution is not normal, the points do not show any systematic pattern that is a straight line pattern, and we would say the points are not reasonably close to a straight line. So we're going to select the distribution is not normal, and the points are not reasonably close to a straight line. And there is our result.